Hello student, in this lesson we are going to solve a real life problem, and the goal is graphing exponential decay functions. As we learn during the class time, exponential decay functions are of the form y equals a 1 minus r to the power of t. Remember, 1 minus r is the factor, and in this case we are dealing with the factor of decay. 1 plus r is the factor of growth. So in this problem, first of all, we have to draw a graph. That's our first job, draw a graph. And since we are going to draw a graph, we are going first of all to analyze what the problem is giving us and what is the most important information so we can take from this problem. So a cup of green tea contains 35 milligrams of caffeine. So it's given, like I can say given 35 milligrams of caffeine. The average teen can eliminate approximately 12.5% of caffeine. 12.5% of caffeine is gone from the system per hour. So it means that every hour 12.5% is going away. So how can we draw a graph here? First of all, I will think that since the caffeine is going away from the body, the system is decaying. So I'm dealing here with an exponential decay function. And as we said, we have the formula for the exponential decay functions here. How can I use this formula to graph? We can use graphing calculator for graphing this problem. So I take the formula and I have to substitute what is given. In this case, A is the initial amount. How much caffeine do I have in the body in the beginning when I start to drink the coffee? So it's given that I have 35 milligrams in the beginning, and 1 minus the rate that here the caffeine goes from your body away, 12.5. I can write that as a percentage, 12.5 over 100. And if I divide 12.5 divided by 100, it's going to give me 0.125. Okay, so I substitute 0.125 to the power of t. And as the order of operation says, 35, I do subtraction here, gives me 0.875 to the power of t. And I have to graph the function. Please use the graphing calculator for graphing the function. I would see a graph that is decay, starting with the initial amount, that is 35, and going down. 35 is the initial, my graph goes down. I never ever cross the x-axis. X-axis in this case are the asymptote. What do you think we're going to put in this x-axis to label the graph now in the contents of the problem? So since here we are dealing with the time, on the x we are going to put the time, or t, and since we are dealing with the y, what do you think the y is going to be in this case? The y in this case is the amount of caffeine that we have in the body. So I can say C for caffeine, how much do I have in the body? And that is measured in milligram. And you can notice that the caffeine in the body starts to go away every hour. So this is the first question, and you understand very well that here we are dealing with an exponential decay function. Okay, so I continue with another question. Another question, I can say question B, is estimate the amount of caffeine in the body after 3 hours. I like the word estimate. Estimate means that we are not looking for the perfect, exactly time. We do the best that we can. We estimate the answer. So how much is estimation of the caffeine in the body after 3 hours? Now, we have the good formula here that we just discovered. So it's y equal 35, 0.875 to the power of t, and t represents the time. So in this case, what is going to happen after 3 hours? It looks like the t is equal 3. So instead of t, I'm going to substitute 3. So y is going to become 35, the initial value, the rate is 0.875, its rate of decay to the power of 3. You can use graphing calculator for that, and you can tell that the number is an irrational number, never ends. That's why we are going to approximate that using our calculator, 23 to 0.45. So the answer is the caffeine in a teenager body will be about 23.45 milligrams after 3 hours. Thank you.